Hello and welcome back to Math with Mrs. Becker. Sorry about that. We were in the middle of our pre-calculus notes for 5.1 and somehow my iPad totally turned off. So you guys, we're just going to pick it up right where we left off. So we are working with our laws of exponents, and what they want us to do is go ahead and write the 10th root of c to the power of 5k. And that's being multiplied by the square root of c to the negative power of k to the power of 1/2 without any radicals. Okay, so we have to get rid of the radical symbols by writing them as rational exponents, and we can only have positive exponents. So that means if we have a negative exponent at the end, we have to make sure that we put it on the bottom of the fraction. Okay, now when you have a 10th root, that is the same thing as having an exponent of 1/10. Remember, whatever this number is, that's your denominator. This is a normal square root. So that means c to the negative k, which already has a 1/2, is now having another 1/2. Well, we have that property that says if you have one base and it has two exponents, you have to multiply those together. So if I take 5k times 1/10, it's top times top, bottom times bottom. So this is c to the 5k/10. Now here, same thing, you guys. C, actually this time, look at that, it has 3 exponents. So I have to multiply all those together. So it's top times top times top, so it's negative k. 1 times 2 is 4. You are multiplying with the same base. So you write the base once. We have to add the exponents. Well, if I have 5k/10 plus negative k/4, well, hold up. First thing I notice is I can reduce this. 5/10 is 1/2. So this is k/2 plus a negative k/4. Well, if I'm adding fractions, I need a common denominator. So I got to multiply top and bottom by 2. So it's 2k/4 plus a negative 1k/4. So we'd have c. Our denominator is a 4. 2k minus 1k is just a k. And I don't have to worry about the whole negative exponent thing because we ended with a positive exponent. So I kept going on this, and then I realized that the video had stopped. So hopefully you join me again so we can finish up the notes. Last little idea for 5.1, transforming fractions with radicals in the denominator to equivalent fractions with no radicals in the denominator is called rationalizing the denominator. Now I know that's super wordy, okay? So here's the short of it. In math, you have a rule that you can never have a square root or a radical. So a cubic root, a fourth root, anything. You cannot have a radical in the bottom of a fraction, okay? If you do, that's not your final answer. You have to simplify it. Simplifying a square root or any radical underneath the bottom of a fraction, that process is called rationalizing the denominator. So what we do, if your denominator is just a single term and it's a square root, you multiply that square root to both the top and the bottom of the fraction. So on the top, this is 7 times the square root of 5. You can only multiply numbers underneath the radical if they are also underneath the radical. So 7 would have to stay up front. Now on the bottom, remember we talked about this earlier. Square root of 5 times the square root of 5. If I take 5 times 5, I get 25. The square root of 25 is 5. You just rationalize the denominator. You no longer have a radical on the bottom because you multiplied top and bottom by the square root of 5. That's what rationalizing the denominator means. Cancel the square root on the bottom. If you have more than one term on the bottom, like here we have 3 plus the square root of 6, you have to multiply top and bottom by the conjugate of the bottom. Remember, the conjugate means that you leave the terms the same, but you have to change the sign in the middle. When that happens, all of the radical signs should cancel. And we saw that. We actually did this process on the front side of the notes. 5 plus the square root of x and 5 minus the square root of x, those are conjugates. Okay, so this problem was helping you to prepare for this last example. Now, when I'm looking at the top, it's 1 term times 2 terms, so I distribute. 2 times 3 is 6, minus 2 times the square root of 6 is 2 square root of 6. It's okay to have a radical on the top. just not on the bottom. Bottom, if I FOIL it, 3 times 3 is 9. 3 times a negative square root of 6 is negative 3 square roots of 6. Inside, 3 times the square root of 6 is a positive 3 square root of 6. Last, positive times a negative is a negative. Square root of 6 times the square root of 6. 6 times 6 is 36. Well, when I look at this, negative 3 square roots of 6, positive 3 square roots of 6, that cancels. Minus square root of 36 is perfect, so it's just a 6. 9 minus 6 is 3. You rationalize the denominator. So again, just wrapping up this last example. If you have a square root or any radical on the bottom of a fraction, you need to rationalize it, which means you need to cancel that radical. If it's one term, you multiply top and bottom by whatever that is. So here it was the square root of 5. I multiply top and bottom by the square root of 5. Check that out. No longer do I have a radical on the bottom. If you have two terms on the bottom, you have to multiply top and bottom by the conjugate, which means to leave the number on the square root the same, you change the sign in between. If you have two terms by two terms, you FOIL. If you have one term times two terms, you would distribute. Here is what the assignment is. It is 37 questions. Some of them go very, very quickly, but because of the number of questions, tomorrow is a work day. So you get the entire 52-minute class period to work on these 37 questions. I will be happy to help you with any questions that you run into or any problems you run into as you are working. I hope you enjoyed section 5.1, and I'll talk to you soon.